Today we're going to talk about some skills that we need to be successful in trigonometry. So the title of our lesson is Getting Ready for Trigonometry. And our first example is using the Pythagorean theorem to find a missing side. So remember that the Pythagorean theorem is a squared plus b squared is equal to c squared, where c squared has to be the hypotenuse. We're pretty lucky in this question because a and b are labeled as a and b, and we're finding c. It's a little bit less work than finding one of the non-hypotenuse sides. So we have 5 for a and 7 for b is equal to c squared. So 25 plus 49 is equal to c squared. 74 is equal to c squared, and we are not going to have a perfect, beautiful answer. Now, after doing quadratics, you might ask, do I need to have a plus minus in front? Normally those are two acceptable solutions, but whenever we're doing Pythagorean theorem, we're finding a length, and lengths can only be positive, so you don't have to bother with the plus or minus. You can skip right to just giving a positive root. If you would like to do the plus or minus and then write it one more time, that's fine as well. And so let's calculate this. About equal to 8.6. Great. So this was a little bit easier, like I said, because we were given a and b and just had to find c. C is already isolated. Had we been given the question in a different way, suppose they had given us that c was 8.6, let's say, and that a was 5, and they asked us to find b, then our solving steps would be similar but a little bit different. We would have 5 squared plus b squared is equal to 8.6 squared, and we would have to move the 5 squared over to get b by itself. You need to remember to subtract the 5 squared because the balancing step would be to subtract from both sides. And 8.6 squared minus 5 squared. Okay, so it's about equal to 48.96. Well, it's actually kind of exactly equal to, but I know the 8.6 was rounded previously, which makes me feel like it's approximately equal. Okay, and to get b, we would square root both sides. And it's about equal to 7. So b is about equal to 7. So that's the two different ways we can work with the Pythagorean theorem, either find the hypotenuse or find one of the sides, in which case we have to isolate. Okay, now let's practice working with proportions. So proportions just mean ratios, fractions, and I'm going to add in a little bit of space. Great. So our first question here, it's fairly straightforward, similar to a linear question. What do we have to do to get x by itself? Well, we need to get rid of that 22 in the denominator. The 22 is being divided by 22, so we have to multiply both sides by 22. And x is equal to 22 over 7. And usually we don't bother evaluating. It won't look very nice, but let's just have a look at what this number is. So indeed, it's not a very nice number, but it's a little bit special. This is actually a number that was used in ancient times to approximate pi. As you know, pi is 3.14159.265, and 22 over 7 is actually quite close. It has the first two decimal places correct. That was used as far back as 2,500 years ago, maybe further back, maybe when the Egyptians were building the pyramids. So that would be like 4,500 years ago. So anyway, it's a pretty cool ratio. Generally, though, I would rather have a fraction than a decimal that's been cut off, unless it's an application question where I have to round, or it starts off as decimals. So here we have some decimals we need to work with. X is in the denominator for question B. We want to get it out of the denominator, and we can do that by multiplying both sides by x. So now on this side, these x's cancel out, and I'm left with only 3.1. And on the other side, I have 15.4x over 31. So I want to get rid of everything that's around the x. If I multiply by 31, I'll get rid of the 31 in the denominator. What I do to one side, I always do the other. And I could write this out and simplify it, but I also know I have a 15.5 that's multiplying with the x to get rid of. So if I divide by that, it'll get rid of that. I did two steps at once. I hope I did not lose anyone. If you're not sure why I did those two steps at once, ask a friend. So I multiplied by 31 to get rid of the 31s, and I divided, I wanted a different color. I divided by 15.4 to get rid of that multiplied by 15.4. It simplifies now. I have 31 times 3.1 over 15.4. And on the right side, everything's canceled except the x. I like to write my x on the left-hand side. And now it's just a matter of successfully putting it in the calculator. 31 times 3.1 divided by 15.4. So it's about equal to, I'm rounding here, 6.24. Double check that one more time. Good. Okay, last question here for these ratios. So this is written in a different format. We usually read it like 2.3 to 5.7 is equal to 8.2 to x, and it really just means the same thing as the fraction. So I'm going to rewrite it as a fraction. 2.3 to 5.7 is equal to 8.2 to x. I won't get into this. It's grade 9 and earlier, so hopefully you're comfortable with that conversion. If not, this is your review. And again, we want to get x by itself, so we can multiply both sides by x and then divide both sides by everything on the other side. There's also a shortcut if you're confident working with fractions. If you have a over b is equal to c over d, it is also true that b over a is equal to d over c. I can flip both those fractions around. You can prove it by multiplying both sides by b, multiplying both sides by d, dividing both sides by a, dividing both sides by c. So I'm going to use that here to flip. If you're not confident, don't do it. Just write out the steps like we did in the last question, where we did all the multiplications and divisions. There's nothing worse than trying to use something and using it incorrectly. Now I'm going to multiply both sides by 8.2 to get x by itself. And now we just need a calculator. And we have that x equals, I like x on the other side, x is equal to approximately 20.3. It didn't ask us for a certain number of decimal places, so I'll just do one decimal place. For our next example, we're going to talk about the parallel line theorems and using that to solve for different angles. So you may remember from grade 9, if you have two parallel lines and another line that crosses it, we can get a bunch of equal angles from this. One rule, I like remembering it by the way the pattern looks, by the letter. So we have the F rule, and in the F rule we know that these angles here and here are equal. We could also easily say that these angles here and here are equal based on the supplementary angle theorem. Remember, the supplementary angle theorem is when you have a line that crosses another line, the two angles here and here will add up to 180. Okay, another rule is the C rule. And the C rule tells us that the inside angles of the letter C will add up to 180. You can kind of slide it over and see why it makes sense. It's basically just that supplementary angle theorem that we saw before. We also have a Z pattern, and we can draw a Z, and then those inside angles of the Z are equal to each other. And we also have that the interior angles of a triangle add up to 180. So those are some important theorems. We would also have a 90-degree angle that's being broken in half. The two angles would add up to 90. So just logical. So let's look at this example. If angle D is equal to 96 and angle C is 38 degrees, find the other angles. So 96 degrees, 38 degrees, and what are the missing angles? So if I use the F rule, it's upside down, but it's here. I can draw an F. That means angle B must be equal to angle D. And when we look at the size of the angles, that's logical. It seems like a good size, but we have the math to support it. It's the angle theorem. Maybe you remember those fancy names for all the angle theorems, but I just remember it by the letter pattern name. Okay, and then we have a backwards F rule over here. That means that angle E is equal to angle C. So we have that angle E is 38 degrees. And finally, to find angle A, what can we do to find angle A? Well, we have a triangle here. We know that the interior angles of a triangle add up to 180. So angle A plus angle B plus angle C must equal 180 degrees. So angle A is equal to 180 minus 96 minus 38 degrees. Okay, 180 minus 96. Well, 180 minus 90 is 90. Take away another 6 is 84 degrees. Take away 38. Okay. Let's do this in our heads again. 84 take away 38. Well, 84 take away 40 would be 44. We're taking away 2 less, so it's 46. Good. So we have 46 for our final answer here. You could go through and double check that everything works out, but we had a lot of repeated numbers, so I think it's pretty obvious that it works out. Okay, so best of luck on the homework, and if you have any questions, please let me know. Your homework is posted, but here it is. Page 314, number 1. That one's a really interesting pattern. I hope you enjoy it. A Pythagorean theorem question. And then on the next page, there's some questions to work with ratios, some more stuff about triangles. So a really nice opportunity here to remember the material that you know from previous grades, get a good understanding of it so you'll have a solid start into trigonometry. Best of luck!